Newton's first law. An object in motion tends to stay in motion unless acted upon by an opposing force, or conversely, an object at rest tends to stay at rest unless acted upon by an opposing force. For example, this is me at rest, and this is an applied force.
Whoa! Why?
Wow! In that example, the force weight I felt while sitting down was equal and opposite to the force normal I experienced from the chair, which is what allowed me to be at rest, or at equilibrium. However, once an applied force was added, aka my sister shoving me off of the chair, since there was no force to be opposite the applied force, I fell out of the chair, which was a movement, and I was no longer at rest because I was acted upon by an opposing force. Anyway, basically what this means is, unless you apply a force to an object, it's not going to move. And if an object is moving, it's not going to stop moving unless acted upon by another force. Newton's second law. Force equals mass times acceleration. This is the equation that Newton derived to explain the relationships between the force of an object, the mass of the object, and how fast the object accelerates. Basically, he determined the amount of force that is applied to an object is directly proportional to the acceleration the object experiences, while the mass of the object is inversely related to acceleration, which basically means that as the mass of an object increases, the acceleration is going to decrease using the same force. And when the force that's applied increases, acceleration is going to increase. This example shows the direct relationship between force and acceleration. My sister's first push only causes me to move a little bit because she only applies a small amount of force. When she increases the force she uses, I travel further and for longer because acceleration increases. Finally, she applies enough force in order that I was thrown out of the chair, similar to the first example. Objects also accelerate in the direction forces are applied to them. For example, in this video, when my sister pushes me to the right, I move to the right. While here, when she pushes me to the left, I move left. And finally, Newton's third law. For every action, there's an equal and opposite reaction. Basically, this means that every time a force is applied to an object, there's an equal and opposite normal force being acted upon by the object applying the force. In this example, my sister and I are standing palm to palm, applying the same force to each other, causing us to remain at equilibrium. However, when I pull away unexpectedly, the amount of force I am applying decreases quickly, and her greater force causes her to fall forward. Life would be pretty weird without Newton's third law. I mean, we grow up learning by interacting with the world around us, and things are pretty predictable when it comes to if I push this object, it'll move about this much, just based on personal experience. Which is why I think in like movies and such, it's always the first law of Newton's to go. Whenever movie directors can, they try and make fights that are way over the top, and like you don't want to see a fight where someone gets punched in the face and they just take it. You want to see someone fly back 10 feet after the hero smashes their fist right into their nose. So to conclude this project, I found one of the most egregious breaches of Newton's third law, and it comes from Kung Fu Panda. So thank you for watching.
You're just a big, fat panda.
I'm not a big fat panda. I'm the big fat panda.
The whooshy finger.
Oh, you know this hold?
You're bluffing. You're bluffing! Shifu didn't teach you that.
Nope. I figured it out. Skadoosh.